So let's just have a look at a static object. The ball's just sitting there. Does that mean there's no forces exerted on it? Well, no, there's no change in motion. It doesn't mean there's no force. It means there's no unbalanced force. There's no resultant force. So, how do we know it's got no resultant force? Because there's no change in motion. If it was flying up in the air, we'd know that there's a greater force going upwards than there is going downwards. If it was falling through the top of this box, we'd know there's a greater force going downwards than going upwards, but it's not. It's no change in its motion, it's just sitting there still. So the forces must be balanced. So how can I change its motion without making contact? We've looked at contact forces. I can poke it, I can blow it. Those both involve contact. The force has to be in contact with the object in order to move it. But there's a very important thing about that, is that as soon as the contact is stopped, the force is no longer acting. It's now rolling on its own. So there's a distortion. I'm poking it. The force is acting, the force is acting, the force is acting, and let's try this again. So if I'm poking it, the force is acting, and now the force is not acting anymore. The only force acting now is a thing called resistance or friction, which is actually acting to slow it down. Okay, so if I look at this and I poke it here, there's a force acting. There's going to be a force acting in this direction, and it only acts for as long as I make contact with that ball. So as long as I make contact, the force is acting. As soon as it loses contact with my finger, that force is not there anymore. And the only force actually acting on it is friction, which is actually slowing it down.